Muito bom dia, pessoal. Hoje, 29 de abril de 2025, pelo horário de Brasília, agora são 5 horas e 51 minutos. Estamos iniciando mais uma transmissão aqui no canal UPTV, hoje com a missão VV26 Biomass, lançamento número 2 da Arianespace em 2025, lá no espaço porto da Europa, em Kourou, na Guiana Francesa. Hoje, então, missão da ESA, né, aí da Biomass, né, satélite Biomass. Este satélite Biomass, né, como eu coloquei já na descrição aí para vocês, né, ele é o primeiro satélite de radar de abertura sintética, né, de banda P, que vai observar a Terra a partir do espaço, né? E o principal objetivo dele, ele é fabricado então pela Airbus Defence Aerospace, Space, e passará então pelo menos 5 anos realizando observações detalhadas e acompanhando pelo menos 8 ciclos de crescimento nas florestas do mundo. As observações desta nova missão também permitirão uma melhor compreensão das taxas de perda de habitat e, consequentemente, do impacto que isso pode ter na biodiversidade do ambiente florestal. Tá? Então, basicamente, ele vai observar as florestas aí ao redor do mundo. Hoje, nosso veículo aí de lançamento hoje da Arianespace é o Vega C. É o Vega C e o tempo de missão hoje é de 57 minutos, o horário para o lançamento hoje está marcado para as 6h15 da manhã pelo horário de Brasília, 9h15 no horário internacional. Já estamos aí com imagens lá na Guiana Francesa. Eu vou transmitir para vocês também agora em conjunto aí. Imagens da Guiana Francesa, aí da Kourou. Faltando então aí 21 minutos para o lançamento. O IPTV sempre mostrando tudo para vocês que acontece ao redor do mundo e na Estação Espacial Internacional. Lembrando que mais tarde então teremos aí a nova tentativa de lançamento para o voo 6 do Alpha da Firefly. Então não percam. E aí estamos aí com a nova abertura aí da Arianespace, né? Abertura bonita. Vai começar o programa Road to Space. Voo 26 Biomass com Vega C. E aí estamos então em Kourou, na Guiana Francesa. Não esqueça de deixar o like aí na transmissão, de estar se inscrevendo no canal. Também, se puder então aí fazer uma contribuição via Pix para melhorar as condições das transmissões e também compra de novos equipamentos no canal.
Welcome. We are live at the European Spaceport in French Guiana on the coast of the Amazon rainforest, and our rocket Vega C is getting ready to transport.
E aí já estamos ao vivo então aí com o Vega C novamente.
Biomass is going to
a missão Biomass.
Of the world's forests, just like the one it's lifting off from, which is vital for tackling climate change. Now we are 15 kilometers from that pad in the mission.
Como sempre, então, só vou dar um ajuste no cronômetro, né? Como vocês sabem.
Samuel Rogers in the commentary box. Samuel from Arianespace, Head of Advanced Studies. Thanks ever so much for being with us, Samuel.
Thank you, Katie. Great to be here. Hi, all.
And if you want to ask a question and you're watching on YouTube, you can pop it into the chat box and Samuel will do his best to answer it later in the programme.
Correct.
Right, now let's go inside the control room to find out how operations are progressing. And the head of the flight desk is David Cavalloles, the CEO of Arianespace. Thanks for being with us, David.
Hi, Katie. Good to be here with you today.
David, Arianespace is
Pronto, cronômetro ajustado. Então, o horário do lançamento aí previsto para acontecer às 6h16, tá? De acordo com o cronômetro ajustado.
So concretely, it implies that we are working very closely with the client, hand in hand, to prepare the mission, typically to define together the best injection strategy for the satellite. Here in Kourou, we perform very important operations to prepare the satellite and to integrate it into the launcher. And of course, last but not least, we are accountable for the launch itself.
And how are things progressing today in the countdown?
Well, overall, the campaign went very smoothly, and I would like to thank the team sincerely for that. One of the key last milestone has been the rollback of the mobile gantry that protected the rocket, the Vega C rocket. So now Vega C is on its launch pad, ready for liftoff, and the launch should happen now less than 20 minutes from now.
Good to hear, and everything's green so far, so good. David, it's an important mission, isn't it? Can you tell us a little bit more about it?
Yeah, for sure. This is indeed a very important mission. The satellite we are launching today is called Biomass. This is a mission for the European Space Agency, which is our client today. And Biomass carries on board a very innovative payload, radar that will watch the forest all around the world, and it will provide very useful data about the carbon cycle. It will be very useful for our scientists, very useful for our decision makers as well. And through this mission, we'll contribute to fight against climate change and also to protect biodiversity. So for this reason, I'm extremely proud in the name of Arianespace to be launching Biomass today.
Great. Thank you very much indeed, David, and best of luck to you and all the teams. David Cavalloles, thank you.
Thank you.
Now, Vega C and Biomass are due to lift off in just over 15 minutes' time. Samuel, what's going to happen after that?
Yeah, so as you said, the liftoff will be triggered by the ignition of the first stage, which we call P120, the first stage of Vega C. It will push for about 2 minutes and 25 seconds, and then a separation command will be sent to separate it. It will then be followed by the ignition of the second stage, the Zefiro 40, which will continue increasing the launcher speed for about 2 minutes. Then this stage will be separated as well, and it will be the Zefiro 9, the third stage, that will take the relay and provide the launcher thrust. Zefiro 9 will push for 2.5 minutes, and during this phase we'll separate the fairing, which was protecting the satellite as we went through the atmosphere. Then Zefiro 9 stage will be separated, and we'll have another important step, the ignition of the upper stage. the Avum Plus, which is a bit different because it uses liquid propellants. After 7.5 minutes, we will shut it down, and then we'll have what we call a ballistic phase, a long phase over the North Pole, and then back down to Australia, where we'll be in contact with a ground station in New Norcia to perform the second ignition of the upper stage. And as we'll have reached the final required orbit, we will be ready to separate our passenger today biomass. Then we'll have another ballistic phase over the South Pole before reaching the last step of this VV26 mission, which will be the third ignition of the upper stage over Cuba. This is necessary to make the upper stage re-entry, and this is very key to avoid leaving any debris orbiting the Earth.
Meanwhile, biomass will be coming alive, ready to start its job. And what an important job it is. It's going to scan the tropical forests just like a doctor to help scientists understand what state they're in and their role in the carbon cycle. And to do that, it has a very pioneering radar which can see right down inside even the thickest of forests to analyse the trunks, the branches and the large shoots, which is where the trees store their carbon. It's going to help us to understand our forests. It's very important. Let's take a closer look.
Agora vamos olhar então um pouquinho sobre a missão de hoje, né? A importância dessa missão. Já tinha falado para vocês. Contando então em 12 minutos e 40 segundos para o lançamento.
as a system and how people are affecting natural processes is more urgent than ever. And Biomass is the 7th satellite in the European Space Agency's Earth Explorer science program to do just that.
Yes, indeed. And in fact, the Earth Explorer satellites actually collect information about all the complex processes of our planet. We can have several examples, typically the motions of the winds or the tides, or measure the thickness of the polar ice caps, or monitor the magnetic field of the Earth. These are typical examples of the missions they are carrying.
And many more. Very, very important program. Just back to our launch, we've had our final weather check. That was at T-10.
Yes, indeed, and the news were good. Actually, we had another check before the removal of the mobile gantry, which we see on the screen just behind the rocket. It was 4 hours before the liftoff to check that everything was fine before removing it. And the last weather check, as you mentioned, was 1 minute ago, and the news were good. So all is fine for lifting off.
Looks like we have a slightly cloudy sky here, but the weather's actually been rather nice these last few days. We've had a bit of sunshine. I can see there on the image the clouds might just part for us for a beautiful launch, and of course sunrise. The European Space Agency teams who will be operating Biomass are standing by in the mission control room at the European Space Operations Centre in Darmstadt in Germany. Just over an hour ago, the Flight Operations Director Jose Morales took the roll call.
All positions on the briefing loop. This is the Biomass roll call. All positions shall report on this loop to me by quoting your call sign followed by go or no go. Some go. AOCS.
AOCS go.
Data handling.
E aí temos então o go no go para o lançamento agora sendo realizado.
Speak on go. Timeline. Timeline go. Project rep.
Project rep go.
PST lead. Software coordinator. Software go. Software support.
Software support go.
Flight dynamics.
Flight dynamics go.
OM.
OM go.
S-track.
S-track go.
Scheduling.
Scheduling go.
Excellent. This completes the Biomass roll call.
Então aí o range do go no go para o lançamento realizado, tudo verde até o momento. Estamos prontos então para o lançamento hoje, hein? Faltando então aí 6 minutos e 50 segundos.
And especially when Biomass will send its first signal home to spacecraft controllers. Back here at the Guiana Space Center, we've got several control rooms. Obviously, this is mission control, but we've got another control room, Samuel. It's launch control, we call it.
Yeah, launch control center. It's if we compare the rocket with an airplane, then the launch control center is a bit like the cockpit of this airplane or the rocket, if you wish. So, and here we can see the team on the screen. They are in charge of preparing the rocket for the last step, checking the parameters, overseeing all these final operations to get the rocket ready for the launch. And of course, once the liftoff will be triggered, the rocket is fully autonomous. It goes autopilot after the liftoff. And in fact, you have two teams. The first one we saw are actually running the operations, and the one behind are checking that the actual parameters are in line with the expectations and checking if any deviation, then analyzing the situation.
Laser focus at this point as we get closer and closer now to the launch. Vega C standing tall on its pad. Now everyone also has their eyes on the status panels. We saw them earlier here in the Mission Control Center, the green panels. There they are on the left-hand side of the screen there.
Yeah.
All green at the moment, good sign.
It's a bit like the traffic lights. If it's green, we can go ahead. If it's red, of course, we'd better stop and analyze. And each of these panels actually corresponds to a person, a team operating or monitoring that system. Could be, for instance, one for the rocket, of course, checking for instance, the tank's pressure or temperatures on board, the status of the onboard computer. Of course, we check also the communication links, the weather status, as we mentioned before, but for sure also the passenger biomass, which has its own status panel, which is on the screen. And of course, if something goes wrong, if there is any parameter that deviates from should be the nominal value, then we notify the range operation manager, and we can hold the countdown time needed to analyze the situation and then assess what the next step should be.
Coming up now to the beginning of what we call the automatic sequence or the synchronized sequence. That's the last 4 minutes. Coming up, just briefly, Samuel, what is that?
À tous de DDO. Attention pour la séquence finale lanceur.
Range Operations Manager.
Então aí temos o anúncio da sequência final de lançamento. 4 minutos.
Top H0 4 minutes.
So what is
4 minutos, então aí, a sequência final de lançamento iniciada.
So currently the computer are managing an impressive sequence of complex operations, each of them timed to the millisecond to get progressively the full autonomy to the launcher.
Now, the job of preparing the rocket and the spacecraft here at the spaceport.
Lembrando que no dia 1º, caminhada espacial número 93 pelo lado americano.
The teams have been working extremely hard during that time to get everything ready for today. Our cameras were there. Samuel, what's been happening?
So first, most of
E aí estamos vendo então um vídeo aí de como foi então a chegada do Vega C na Guiana Francesa e a sua integração.
ready for liftoff.
Indeed, and here we are, 1 minute and 31 seconds now to launch, hoping for a very beautiful dawn launch. Getting close, quite tense at this moment before launch, isn't it?
Yeah, we can clearly feel the intensity, the concentration, all the teams are focused on their task.
À tous de DDO. Attention pour moins 1 minute.
Coming up to 1 minute now to launch.
Top H0 moins 1 minute.
We are live at the European Spaceport in French Guiana, getting ready now for the launch of Biomass for the European Space Agency. Good luck, everybody.
Good luck.
À tous de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage P120. Décollage. Propulseur nominal, début du basculement. Propulseur nominal. Pilotage calme. Trajectoire nominale. Acquisition Saint-Jean. Trajectoire toujours nominale.
Sunrise over the Amazon rainforest, and Biomass has started its journey, blazing a trail on
La
board the
trajectoire est
Vega C
nominale, le
rocket
pilotage est calme.
on its quest to understand forests just like the one it's lifted off from, on its mission for Earth and for our future. We can hear it flying
amazing.
over the
Amazing pictures, and yeah, we can feel the the walls
shaking here
shaking, wow.
at the Jupiter Mission Control
Trajectoire
Center.
nominale.
He's telling us that everything is going well.
Yeah, so far it's perfect. We are lucky to see it so long. It's given the clouds we had at the beginning.
Getting some great views here from our cameras. Burning the P120 first stage here, which is getting us away from
La
the
trajectoire est
gravity.
nominale, le pilotage est calme.
The gravity of our planet. The range operations manager there telling us that the trajectory is nominal and the pilotage, the piloting,
Yeah, control of the thrust.
No momento tudo segue em
The
ordem.
orientation of the
Aí
thrust
com o
of
Vega
the
C,
rocket. It's nominal means everything.
sua decolagem aconteceu às 6 horas e 16 minutos, pelo horário de Brasília.
on the separation of the P120 will be the first event.
La trajectoire est nominale.
Everything's going according to plan. Fantastic
Potentially,
views.
we could see it from the cameras. It could be nice. Yeah, should occur in a few seconds now.
Indeed, this is the scheduled moment for the
And you can
separation.
see it on the,
Séparation P120.
and it's just confirmed.
Allumage Z40.
So he's just confirmed that we've separated the
La pression est
P120,
nominale. La
first
trajectoire est nominale.
the stage. We've switched on the second stage, the Z40. Everything's going normally. And Z, what does that stand
Z
for?
is for zephyro. It's an Italian name for a type of wind, because I guess it's a bit windy when you're on
Trajectoire du
board
lanceur nominale.
such a booster.
Look at that. Fantastic. We're seeing it. We're 3 minutes and 11 seconds into the launch, and we can still see it with our cameras, which is very exciting. So we've got clear skies here at the Guiana Space Center.
Amazing, yeah. Wow.
We had several weeks of rain, and suddenly it's been very clear
La
and
trajectoire
beautiful.
du lanceur est nominale.
He's telling us that the trajectory of the rocket is normal.
It's perfectly as planned. Yeah.
And of course, the fairing, which is where our satellite is encapsulated at this point, Samuel, is the nose cone, if you like. We saw it before
La
the launch,
trajectoire est nominale, le pilotage est calme.
and
It has a multiple.
it's got a number of jobs, hasn't it?
Yeah, exactly. Yeah. It basically protects biomass from a number of environments. First, of course, the Guiana environment, the rain and the dust, everything. But also at liftoff, we have, when we
Début que de
fire
poussée.
the booster, there is quite a high acoustic vibration environment. Then the fairing is used to damp it, and as well to
Trajectoire
Nós já
nominale,
estamos aí
pilotage
com
calme.
dados de
as we go
telemetria
through
do
the
Vega
atmosphere,
C.
it helps
Até o momento sua
reducing
trajetória
the
continua normal e o
heat load
pilotagem calma.
generated by the friction with the atmosphere or the vibration. So it's quite a clever piece of hardware. Yeah.
Very important. You can see it at the front of the rocket there, the sort of bulbous section. Right, we have now the scheduled moment to separate the Z40 to jettison that.
Séparation Z40.
That's
So we
been
just confirmation that the Zephyro 40 stage has been separated,
and
Allumage Z9.
and
we've switched on the engine of the Z9, and we've also waiting for
Propulsion
confirmation
nominale.
of the fairing jettisoning.
Séparation des coiffes.
And we have
we have
confirmation.
it. Yeah.
So we can see our satellite for the first time, Samuel. Why don't you explain to people what we're looking at here on these computer-generated images?
Yeah, on the left of the screen, you can see on the right,
Trajectoire
Biomass
nominale.
passenger with, of course, its radar and solar panel folded. It's attached to what remains of the launcher, which is rather small as compared to what was on the pad, through the adapter, this black cone, and then you have the upper stage, which is a tiny, a white slice of the launcher, and on the
La
left,
trajectoire du lanceur est nominale.
the Zephyr 9 stage, which is still thrusting our passenger into space.
And of course, once Biomass is separated from the mothership, it'll unfold its solar wing. It has one solar wing made up of 4 solar panels. And of course, it's amazing, great big reflector, which looks like a huge space umbrella.
Yeah.
So quickly, let's just explain to people what we're looking at on the screen. So we've got the 3D images, which are computer generated.
Yeah, and they correspond to the plan.
La pression chambre est nominale, la trajectoire est nominale.
It illustrates what the launcher plus biomass behavior should be in space, the orientation towards the sun or towards the Earth, for instance. Of course, the altitude, the different stages separation, as we saw, and of course the real orientation and firing, as we see here.
You can see on the left side of the screen are the various events that as they happen, and then on the right hand side of the screen the trajectory, and we also have the altitude. At the moment we're 663 kilometers high.
Trajectoire nominale, pilotage
263.
calme.
Yeah.
Sorry, so 263.
Yeah.
We will be getting closer
Exactly.
to 600
Not
later.
yet.
And our distance is our distance from the pad. If you were to draw a straight line across our planet, and look at that speed, we are travelling, Samuel, at 7.53 kilometers per second.
This is quite fast, yeah. This is roughly, 8 kilometers per second, just for people to have an idea, is 30 times the velocity of a commercial aircraft. So it's fast.
Séparation Z9 confirmée.
About 28,000 miles per kilometers per second.
Per hour. And here we had just confirmation of the separation of the third stage, the 09.
Indeed. And we can
Acquisition
see
de la télémesure par la station Bermude.
there he's announcing that we're picking up the signal at the Bermuda tracking station, which you can see there on the globe. Bermuda, of course, in the northern Caribbean.
Orbite du Z9 correct.
I'm sure it's all very sunny as the sun rises there. Very pleasant weather, I'm sure. Checking in there at Bermuda and saying hello to the teams. So our flight path takes us, north, up over the North Pole?
Exactly, yeah. We'll fly after the Canada, we'll fly over the Arctic, and then back down over Southeast Asia and to the west coast of Australia, where we will separate biomass.
Début de la manœuvre d'orientation pour le premier boost à Vom.
So he's saying we are orienting doing a set of maneuvers to orient correctly the launcher to fire the upstage Avon Plus, which should occur in a second or two.
Allumage de la Vom.
So we have confirmation that the Avon Plus upper stage has switched its engine on, and that's an important moment, an important milestone. We've really now started the next phase of the journey, because the
Propulsion
Avon
nominale de la
Plus
Vom.
is a little bit like our orbital taxi driver. Its job is to deliver our passenger to its drop-off point in space, and that's a very important job.
Yes, indeed, and it's the Avon Plus job, as you said, to deliver biomass exactly on the right orbit, in the correct orientation, and to do that, we need to perform with this upper stage precise set of maneuvers, and we'll see two
Fin de la
firings.
poursuite Saint-Jean.
This is the first firing, and we'll have another one later in the mission, and this will enable to reach the separation orbit,
Propulsion du lanceur nominal, pilotage calme.
which is circular at 670 kilometer altitude in about 49 minutes.
Fin de visibilité Galio. Trajectoire nominale, propulsion nominale.
So we've gone out of the range of the Galileo tracking station. That was the tracking station here at the spaceport, and everything's going well. Big space projects like Biomass involve hundreds, sometimes thousands of people pulling together to make them happen. They involve brain power, teamwork, lots of problem-solving skills.
And potentially lots of coffee cups as well, or tea.
Lots of cups of tea in this case, yes, because Biomass has been designed, built and tested by the European aerospace giant Airbus Defence and Space, and a lot of that's been done in the UK.
And they are what we call prime contractor, so it's like they are conductor of an orchestra.
Propulsion nominale de la VOM, pilotage calme.
It means they manage a group of companies and suppliers. Each of them play a super important role, and we have many industrial teams from Europe, but as well from US or Canada, which were involved in delivering hardware for Biomass. And in particular, as you mentioned, the satellite platform was assembled in the UK, indeed.
In fact, I was lucky enough to see it because I was filming there a little while back, and it was really exciting to see Biomass in the clean rooms taking shape. Big shout out, actually, to my fellow compatriots in the UK, Airbus in Stevenage. So let's just check where we are in the flight. We are climbing.
Close to 300 kilometer altitude. And 3,000 kilometers.
La trajectoire de la VOM est nominale.
So trajectory is perfectly on the target. We are running gently the propulsion of the Avon Plus, consuming propellants.
And we're coming closer now to picking up the signal at the Gatineau tracking station. You can see it there in Canada, the northeastern coast of Canada.
Acquisition de la télémesure par la station Gatineau.
He's just confirmed that we've picked up the signal there. It's a bit like a relay race, isn't it?
Exactly, yeah.
Handing the baton from one tracking station to another.
Yeah, we want to be sure to have contact with the launcher during this phase while propulsion is active to receive the parameters.
Pression nominale des réservoirs, le pilotage est calme, la trajectoire est nominale.
Everything's going normally. So the rocket's talking to us, it's sending its signal back down to the tracking stations, and they then transfer that information to the telemetry team here at the spaceport. We call them the CVI in French, or the Quick Look Telemetry Team. And we can see them actually in the bottom right of the screen there. Our colleagues, your colleagues there, Samuel, they're on a hilltop, aren't they, just outside the spaceport?
Yeah, very close to the spaceport on La Montagne des Pères. And they are actually, as you said, receiving the major flight parameters from the launcher
nominale de la VOM.
all along the flight, thanks to these antennas which are located on the
Il reste 3 minutes de propulsion de la VOM.
On the path. And it's a bit like the doctors who are checking the health, monitoring what's happening on board, checking everything's fine, as expected. And you can see here my colleagues Michael Krebel, who is in charge of the team, and also Armel Giral, together with Avio and CNES colleagues. And this is, as we said, possible thanks to the different ground tracking stations located first were in French Guiana, then in Bermuda, then in Canada, and last one will be in Australia, as we mentioned.
Now, one of the features of the Avon Plus upper stage is that it can restart its engine again and again. We have another team here in the Colleferro in Italy.
Yeah, indeed. There are teams from Avio, the rocket manufacturer, and they are checking from Italy that the launcher behavior is fine, analyzing the data.
Pas d'écart en altitude, trajectoire nominale.
There are people from different teams, such as propulsion, structure, control,
Le lanceur est mis sur orbite.
and they are available and ready to jump if needed as a support team, so it's very useful.
And indeed, as you say, they are the manufacturers of the rockets, so it's very useful to have them there and to have as many people on the job as possible. Indeed, as I was saying, one of the features of the upper stage is that it can switch its engine on and off, and that's actually very important. Why is that?
Yeah, it's very key because it's a major asset of this upper stage, because it makes possible to take different passengers, like you say,
Pas d'écart en altitude, la trajectoire est nominale.
Like a space bus, to put different passengers to different orbits, but in the same launch. So this is really key, and with this upper stage Avon Plus, we can fire it up to 8 times, and this is much more than the previous 5 on little sister Vega. And so it's very helpful to deliver several satellites on typically 3 different orbits we can reach with Vega
Reste 1 minute de propulsion de l'avant.
on the same
La
mission.
propulsion est nominale, trajectoire nominale.
So it's really a key asset for our customers indeed.
And it means that you can take pretty well any satellite to any orbit, and that's very important, that level of flexibility.
Yeah.
And we're getting ready now, the Avram upper stage is getting ready to switch off its engine. How does it know when to switch it off?
In fact, this is based on its initial position, which we feed the launcher with on the pad, and then it has clever instruments along the flight, computing where it is and how it's oriented, what's its velocity all along the flight. So
Propulsion nominale, pilotage calme.
it knows precisely where it is and when to stop it, and which should occur soon.
We are 329
Fin de la
kilometers
visibilité par la station Bermude.
above our planet. We have now gone out of range of the Bermuda tracking station, and we're being tracked by Gatineau, getting ready to switch the engine off.
Propulsion
Waiting.
nominale, pilotage calme.
For the confirmation
Extinction
there.
de l'étage avant.
And we have the switch off of the upper stage engine now confirmed, so that's really good. Why now? Why do we switch it off now?
Par l'étage avant correct.
So it's just saying that when we stopped the engine, as I was saying, we were exactly on the point we wanted to be. So this is really a good news. And why do we stop it? We stop it because we are climbing to just below 700 kilometers, and we'll do it in 2 steps. So here, this is the first step, and we have reached the
La
target for
pression
the
des
first step.
réservoirs est nominale.
So we just stop it, and it's all very normal as planned.
Now, today's launch is the
Orientation
result
pour le mode
of
barbecue.
years of collaboration across many, many teams, and we've been talking to some of them. Let's hear from them now.
Seis horas 34 minutos pelo horário de Brasília. O lançamento então foi realizado com sucesso às 6 horas 16 minutos, lá na Guiana Francesa, com Vega C. Até o momento segue aí na sua trajetória normal. Vocês podem acompanhar na sua faixa direita, ali nos dados de telemetria do veículo. Tempo de missão agora são 19 minutos. E o PTV sempre mostrando tudo o que acontece ao redor do mundo e também na Estação Espacial Internacional.
The upper stage delivers biomass onto its orbit. The teams at the European Space Operations Centre, which is in Darmstadt in Germany, will take charge of flying their satellite.
Yeah, and first biomass should call home, then it will unfold its solar wing and start all the process of being tested before actually it can begin its job of scanning our forests, which should start in 6 months from now.
Indeed. And the teams at ESOC operate all the European Space Agency's satellites. That's more than 90 of them over the years. And they also take care of ESA's network of tracking stations. They provide world-class expertise for flight dynamics and mission operations. And it's also home to ESA's space safety program. So it's a busy old place. Thomas Ormiston is a spacecraft operations engineer, part of the team flying the satellite. So he's one of the people in charge of flying biomass today. Let's go to Thomas now.
And hello, welcome to Mission Control here in Darmstadt, Germany, where the team are calm, sitting back, enjoying the ride for the time being as we carry on the journey of biomass to space. They're all getting ready for that moment we're hoping for a bit later on, where we'll pick up the signal. But for now, we can enjoy standing here, and I'm here very happy to be joined by biomass mission scientist Bjorn Roman, who's going to tell us a little bit more about what biomass is going to do. So thank you, Bjorn, for being here. It's your baby. How are you feeling having seen that spectacular sight?
Yeah, spectacular launch, Thomas. It was great to see it from here. We're also joined here by a lot of people from the science team. We've been waiting for this for years, and of course waiting now for the spectacular things that are to come after the launch.
Absolutely, and I saw the emotions on people. It's quite a moment here, and there's still more moments to come. Now, tell us a bit more about this. One of the key goals of biomass is to study the role that forest biomass plays in the carbon cycle. How is the data from the mission going to help fill in humanity's understanding of this?
Yes, Thomas. A very good question. The main science question of the biomass mission is really to try to unravel the main unknowns that we have in the global carbon cycle. As people know, most of the actual CO2 emissions that are going up in the atmosphere are coming from the burning of fossil fuels, but the remaining part is coming from land use change, and most of it can be attributed to deforestation. And this is and on the other side, there's of course as well then the actual sinks. About half of it, what we're actually emitting, remains in the atmosphere. About 3/10 is going back into the forests. So this is actually a very good thing. This is actually one of the few things where forests are known for, is that actually there's a very natural way of capturing carbon. And actually the forests are growing from it. So it's actually a very, very nice thing. The remaining part is going into the ocean. And for the oceans, actually, it's kind of a bad thing. You get an acidification of the oceans, which is really detrimental for the ecosystems and biodiversity. On top of this, the biomass mission will especially look at the tropical forests. And this is exactly the areas where the largest unknown, so we have a gap in our knowledge. And on top of this, there's also the place where we know the largest changes are occurring.
Yeah, exactly. And I mean, when we're looking at those things, I mean, we've had radar missions from ESA before. These are studied in other ways. I mean, what is it about biomass's radar that makes the technology so unique and so special for this?
Yes, I can tell you about this, Thomas. So as you mentioned, ESA has been flying radar missions before, and the type of mission that they're flying, type of technology, synthetic aperture radar, we're flying this actually already since 1991, ever since the launch of ERS-1. So SAR is not new to us, but what is new to us is especially the frequency that we're flying. We're flying for now with biomass. We're flying the lowest frequency used for Earth observation for radar imaging ever used by mankind. So this is a really unique, and with this wavelength, we're able to actually penetrate down to actually the forest and down to all types of natural media, which would give us additional new information, complete new information on our planet. And in the forest, we're able to be actually sensitive to the larger structures that we see in the forest. So think about the branches and the stems, and this way we can get, let's say, really new information that we can then later on relate to forest biomass and forest height.
Excellent, amazing. And I mean, I understand these forest ecosystems are incredibly diverse and varied. I mean, biomass, I think, will allow scientists to differentiate between the different types of forest to measure the biomass. I mean, how's it going to do that?
Yes, this is a very intricate process with a lot of very interesting algorithms that we're going to do. The first thing, of course, we get the data from the satellite, and with this, we hope to be able to estimate biomass, but as well forest height. Together with these two, we hope to be able to constrain our solution space in the end. What we have on top of this with biomass is that we have a very exciting first operational phase of the mission where we employ tomography. And it's actually the first time where we systematically employ this type of operations during a mission. And with the tomography, which you can compare like with a CT scan when you have to go to hospital. Hopefully you will never have to see this type of device, but it's able, let's say, to slice 3D slices of the human body. And we're doing something similar in the forest. So we get information on the 3D structure in the forest, so we get a 3D view on what is happening there. And with this, we hope to get as well additional structural information that we can relate to different forest species and different forest biomes.
Wow. Really fascinating. And I mean, yes, so biomass is one of our Earth Explorers. The Earth Explorers all have a topic, and biomass is focused very much on forests. But are there other areas you expect this mission to contribute to?
Yes, for sure. We're actually counting on it. This will be, as I mentioned, is the first time we're going to fly P-band, this 435 megahertz frequency. And with this, of course, we're going to basically, for the first time, look at our planet with what I call P-band goggles. So we really are going to unravel completely new things about our planet. And this is always when you fly something new with a new wavelength, you will see completely new things. But we have already identified a few areas for which we know there's a good chance that we can do some real nice new science. One of them is looking at the forest floor. As I already mentioned, that we're going down with a signal, we're able to penetrate down to the entire forest layer. And we're actually also sensitive to information we get from the forest floor. Now, with other systems, we always get to say out at the top of the canopy a bit, but we never can create, let's say, a digital terrain model from the forest floor. And about 30% of the land is covered by forest. So all the DTMs that we have, the terrain models and the digital elevation models, they have a kind of an unknown area. They are not able to precise accurately what actually topography is doing there. So this is something that we hope the mission will also be able to contribute to. A second one is we're looking at ice in the Antarctic, the land ice in the Antarctic, and how it is actually moving. So there are other missions that are doing the same thing, but because again about our penetration into the ice, we'll be able to get access to additional volume scattering that hopefully is going to be stable over time to be able to follow this as well, in addition as well to ice structural information. Then another one that's also very exciting is actually that we're able to look at the deserts and look at paleohydrology. So looking at ancient rivers been dried up, and maybe some remains of ancient civilization that were living in deserts at the time they were not deserts. So this will be, and of course, Thomas, this is not everything. They're going to be for sure, as I said, looking with P-band at the planet, we're going to be in for some surprises there.
Wow. I mean, really, really exciting stuff. And yeah, I think we can all be very, very excited about the science surprises. I would say, though, as an operations person here in this room, we don't like surprises. We hope everything goes according to plan. So far, indeed, everything is good. You can see on the board behind me that we're all green. ESOC is very much ready to take control of the spacecraft when it separates not long from now from the upper stage of that Vega C launcher. But for now, I would like to say thank you very much to our launcher for giving us a gentle ride. We will continue enjoying it here in the control room, and we will be back to talk to you later once we've separated to catch that all-important moment of first acquisition of signal. Thank you very much. Back to Katie.
Thank you so much, Thomas and Björn. So great to hear from you both and have such a fantastic description of this terribly, terribly important satellite. Okay, so we're going to take a break now because we're coasting without the engine. So we're going to cut our mics for 20 minutes. We're coming back at 7:05 Kourou time. That's 11:05 here in UCT, Universal Time, 12:05 in Paris. And if anyone wants to ask a question,
put them in the chat.
Yeah, put them in the chat box on YouTube or any of the social media. I think you'll do your best to answer later. Okay, see you in 20 minutes. Bye.
Goodbye.
We are 51 minutes into the launch of Biomass for the European Space Agency, and those images were the launch, which took place 51 minutes ago. We lifted off from the pad here at the spaceport, and right now Biomass, our very precious satellite, is hurtling through space, attached to what's left of the upper stage. I'm Katie Haswell, and joining me in the commentary box is Samuel Rogers. Samuel, great to have you with us. Thank you.
Thank you. Great to be back.
Yeah, Samuel is a real rocket science expert. We're very lucky to have him in the commentary box. Samuel, just run through what's happened for anyone who missed the beginning.
So we had the first phases of the flight were for the ignition
Acquisition de la télémesure par la station Nunancia en Australie.
He's just letting us know that we've picked up the signal at the new Norcia tracking station in Australia, so we're checking in with the teams there.
So we had main steps were first stage burning,
Le
so
pilotage est calme
320.
de l'étage avant.
Then we had the second stage, Zefiro 40, for a bit more than 2 minutes. Then the Zefiro 9 for 2 minutes and a half.
Estamos aí então
And
no
then
processo
the first boost of the
final
Avon Plus
para
upper stage
a liberação
of
então
Canada,
do
and we had
Biomass.
a long pause over the North
52
Pole
minutos de
without
tempo de missão
propulsion. And then
percorrida.
we have just had
Estamos aí
contact
então
with
na
the New Norcia ground
aguardando
tracking
então
station, and we'll
a
be
segunda
ready soon
ignição
to fire the
do Avon.
Avon Plus again for the second time.
You can see on the left-hand side those events, what's coming up and what's already happened, what's happened in blue, what's coming up in white, and our telemetry on the right-hand side of the screen. We've got some hot news from the Guiana Space Centre. The team's tested a new solid propellant rocket motor called the P160. That was a few days ago.
Yes, indeed, and it's a major
Début
milestone.
de la manœuvre d'orientation pour le deuxième boost Avon.
I will interrupt while he is speaking. It's a major milestone because it's a key development for future
Fin de la
upgrades
manœuvre d'orientation.
of both Ariane 6 and Vega Europe's launchers. This new motor is 1 meter
Pression
longer
réservoir nominale.
than the P120, and it carries 14 tons additional propellant.
And we've got here the switching on,
Allumage
that was the
confirmé de
switching
l'avant.
on of the upper stage, which has now been confirmed. And here's the picture. We can actually see the hot fire test there of the P160
Propulsion nominale, pilotage
firing
calme.
up.
And it's really key because it will increase the Ariane 6 and Vega performance, their payload capacity, and their competitiveness. So really a very good complementary development for these
Trajectoire
launchers.
du lanceur nominale.
He's telling us that the trajectory is normal, everything's going
No,
according to
let's
plan
do
up
the
there in
opposite.
space. We've had a question from somebody called X who is asking Samuel, why does the fourth stage burn for so long? Is it in orbit yet?
So yeah, we are in orbit, but not at the right altitude. So we are, in fact, we are in a we are like in a roller coaster. So first we have picked up some speed thanks to the solid
Pas d'écart en
boosters.
altitude, pression chambre nominale, trajectoire nominale.
Thanks to the solid boosters and the first Avon burn, then for the first 16 minutes of the mission. And then at the end of this first boost, we were at the bottom of the roller coaster, starting moving up. And during the break, we have slowly lost speed, but we moved up to higher altitudes. And in physical terms, it means we have transformed the kinetic energy, meaning the speed, in potential energy, meaning altitude. So now we are close to reach the top of the roller coaster at
Il n'y a pas d'écart en
670
altitude, la trajectoire est nominale.
at 670 kilometer altitude. So it's the right time to fire again the upper stage. So in other words, we were in an elliptical orbit and we're waiting to get to the apogee. This is the highest altitude point to burn again the upper stage and circularize the orbit. This is the technical term for it.
So it's a
Propulsion
bit like
nominale,
we were at the top of the
trajectoire
roller coaster,
nominale.
and instead of coming back down, we just keep on flying.
Exactly, flat.
Slightly
To keep-
terrifying
to keep-
concept.
Extinction
Right.
de l'Avon.
We've had the confirmation there that we've switched off the Avon Plus upper stage, so that's good news. Another very important moment. So as you say, we're
Orbite
on
atteinte par l'Avon
altitude.
correcte.
And this is a precise, very important
Estamos aguardando
information.
então o
The
momento da
orbit
liberação
manœuvre
aí da
d'orientation
do
de
Biomass.
Biomass.
we have just reached is the right one. So now we're performing a quite
56
maneuver
minutos.
to orient the satellite
Missão
plus what
percorrida.
remains from the launcher to point the
Menos
satellite
de
into the right
alguns
direction,
segundos, então teremos a
required by the
confirmação então
customer
do
for
Biomass, da
biomass
liberação do
separation.
Biomass.
So it'll take 1.5 minutes, and then
Pilotage calme.
we'll be able to separate biomass by releasing the clamp band which was attaching the spacecraft to the black cone here, and then there are a number of springs that will gently push biomass away from the launcher.
We're effectively going to ping it into orbit so that it'll move away from the mothership. That's coming up in less than 30 seconds now. Very precise orientation maneuvers up there in space. These computer-generated images showing us exactly what's been planned for today's mission.
Fin de la manœuvre d'orientation.
So we have reached the end of the maneuver.
So we're getting ready now to separate biomass.
Séparation biomasse.
Nice.
Merci
We have
d'attendre.
confirmation there that we have separated the biomass satellite. This is wonderful news.
Great news.
Congratulations to all the teams, everybody involved.
Nous
This has
attendons
been,
la confirmation de l'acquisition du signal du satellite.
he says we are now waiting for the confirmation of the acquisition of the signal of the satellite. That is, of course, when the satellite will talk to us.
Say this, hello to
And
the
say hello. It'll call home to the teams at the European Space Operations Centre who have now taken on their new baby. And we're hoping to hear now from the CEO of Arianespace, again, David Cavayoles, who spoke with us earlier. And look at those wonderful images there, the computer-generated images, the CGI animation of biomass. It looks like it's floating away, but it's actually travelling incredibly fast still, isn't it? It was 28,000 kilometres a
It's
second.
fast with respect to
A
the
minute.
ground, but it's slow with respect to the launcher. We want the separation to be gentle, not to have too high speeds to avoid any risk of collision. So it seems to be slow, but it's really fast with respect to the ground.
Estamos aguardando então a aquisição do sinal aí da
Teams here in the Mission
Biomass.
Control Center, everyone very, very delighted now that we've had the separation. So let's go over now to David Cavayoles, who joins us once again from the fishbowl. David, thanks ever so much for coming to talk to us. So good news.
Yeah, absolutely, Katie. I'm absolutely delighted to announce that today the Vega C launcher, operated by Arianespace, has successfully placed into orbit its passenger, the Biomass satellite. I would like to very sincerely thank our client and partner, the European Space Agency. And today, with this launch, not only we reinforce the autonomous access to space for Europe, but also we contribute to make better life on Earth and to protect biodiversity. So this is really a huge achievement, and I would like to say a big congratulations to all the team involved, and thank you very much, and thank you to all our viewers all around the world.
Indeed, and it's a busy time here at the
Fin de la
spaceport, isn't
manœuvre
it, David?
d'orientation
Lots
de
of
la boom.
launches.
Les pressions sont correctes dans les réservoirs.
So, David, thank you very much indeed for coming to the floor and chatting with us. We wish you and the teams the very best of luck now for ongoing operations. David Cavayoles, thank you very much.
Thank you.
So, good news, Samuel, for good news there. We've separated our satellite, and we're now waiting for the Biomass satellite to call home and talk to us. And this is going to take a little while because we have to wait for the satellite to come over the horizon, I believe, and for the spacecraft controllers at the European Space Operations Centre, which is the European Space Agency's operations centre, their mission control, where they fly the satellites. waiting to hear from them later in the programme. But first of all, I'm absolutely delighted. I've got somebody very special joining me here in the commentary box. She is the principal investigator, one of two principal investigators for the mission. Her name is Thuy Le Thuan. And Thuy, I am absolutely so happy that you've been able to come and talk to us. Thuy, before we talk about anything else, you must be absolutely delighted.
Okay, I feel so happy and it's beyond words.
Bem, eu vou estar encerrando aqui a transmissão por aqui, tá? Muito obrigado por assistir a nossa transmissão aqui da Biomass voo 26, aí, então aí da Arianespace, com Vega C. Nos vemos então daqui a pouco para a transmissão então aí do Atlas C, do Alpha, do Firefly, a partir das 10 horas da manhã. E o PTV sempre mostrando tudo que acontece ao redor do mundo e na Estação Espacial Internacional. Até mais tarde.